Hi and welcome. This time around I have another couple interesting jigs I've got to make for same customer as last time. And this one's kind of interesting because, well, for one thing, jigs really fascinate me in general. But this project is going to challenge me in some ways that I haven't been challenged before, which is figuring out how to make things that are constrained only within the limits of what the project requires, not necessarily what you could do. And so when I first thought about this, basically I'm going to explain what you need. So they need a holder that will align this very small piece of steel or whatever the material is made out of at a very specific distance from the center line of all these parts. However, the orientation this way is not relevant. It's totally unimportant to this. So I don't need to like find two holes and line the pins up, or all the holes and line the pins up so they fit exactly. Also, these holes, I don't know if you can tell on camera here, only the center one is round. It's 0.454, and the other ones are all oval shaped. So at first I thought, geez, how am I going to make an oval pin to fit in those? And then I realized I don't actually need that because I don't care about any side-to-side orientation. Now what I could have done is had one pin in the center and like a couple on the side that would stop rotation, or just one on the side potentially, and that would stop rotation and side-to-side position because the center one is round. But it turns out I don't even need that. Two holes spaced out, or picking 2 points spaced way out on the edges with the slots. Going back here showing you their slots. They're about 30-some thousandths wide. Means that I can even be off a little in this direction and it won't matter, as long as the distance from the center line here to the end of this jig is within spec, which is plus, well, let's see, up to plus 5 thousandths minus 0 of the edge here. So that's where we're actually looking for. And I think this should be an interesting project because, again, jigs fascinate me. There's definitely an art to it as well as the science, and a lot of people are really good at it. But there aren't a lot of good books out there on how to do it, so you're sort of learning on your own every time. If you go to a manufacturing engineer that's been doing it for years, I'm sure they'd have all kinds of tricks and cool solutions to making this sort of thing work. When I'm done with the jig, since what I'm going to use, let me come over here. I'm going to use this ATP5. This is tooling plate, and it's very, very flat and same thickness all the way through. So what I'm going to do is I'm going to drill and ream some holes in here after cutting one side to be square, which is probably fairly square to begin with because these are sheared. Actually, they may have used a table saw to cut these at the metal place I got these from. Anyways, I'm gonna drill and ream a hole, and then I'm going to make some custom pins that are 0.454 on the outside, but smaller to fit the holes that I'm going to ream through the tooling plate here. Space. This is 5/16 tooling plate, so it should give a decent hold on it. I'm going to make the pins sliding fit in here, and I'm going to Loctite them in place. And then that piece of aluminum will fit on top of this part and help align for this little metal piece here that's sitting up here to be aligned, which turns out to be right on the edge of this slope, or the back side of it right on the edge of the slope where it will be affixed. So that's the job, and I have two of these of slightly different dimensions, so I don't know if I need to show the second one, but I thought this was interesting enough that worth showing. All right, so here's the setup I've got here. Two sets of adjustable parallels. I bought those early on because if you ever want to do two things that are some sort of random thickness, they work out really well and they're handy to have. I've used multiples more than once, so it's a good thing to have. They're kind of expensive, so I get it. So what I use those for is I put those in my T-slot to line up the back of this part. Now, this is going to be my reference edge where I'm going to need to be a specific distance away from, specifically 2.641 inches. However, the interesting thing here is that the fact that these two parallels are only roughly in line with each other, probably within a couple thousandths, maybe 5 thousandths, 10 thousandths kind of thing, it doesn't really matter, because what I'm going to do is first I'm going to establish a reference edge here. I'm going to take an end mill, I'm just going to cut along this whole edge, and I'm going to create my reference in line with the X travel of my mill. And then I will use an indicator an edge finder to find the edge here and go in exactly 2.641 inches from both of these points. And I put little blue dots roughly in line with where the holes are supposed to be. That way, it doesn't matter if this back edge, like this is a saw cut edge back here, so it's not necessarily square either. It doesn't matter that it's not exactly square. So one issue I came up with is where my placement of the clamps puts them fairly close to the edge here, which means a 1/2 inch end mill. I'd have to have a fairly long one to get down far enough to reach this with not having the quill and the spindle run into the clamps, which I could do. I could remove these clamps, but I have a 3/4 inch aluminum cutting end mill. And I know that's a lot of stick out, but I'm going to be taking a very light cut in aluminum. So I am kind of curious if I can actually pull this off. Although I realize I think I'd prefer to do a climb cut. So this is a conventional cut, so I want to come from this side and go this direction to get a better finish. So we will head over. There's about 10 thousandths depth of cut. Surface finish feels really good. So we're just replacing the saw cut here with a milled cut, which will be a lot, and something that is parallel to the x-axis travel of the table and should be fairly close to dead on. All right, so I've gone to both extreme ends, found the middle, which lines up with my dot, which I just used the tape measure to find the middle of, but it lines up nicely, so that's the first thing. So now we're going to come in and find our Y0 very carefully. And we're going to call that Y0. And then I want to make sure it repeats, because this measurement is important. So there's my Y0 again. And let me come up and go in 100 thousandths. I should have just dialed in minus 100, or 100 rather, so I could have been 0. Okay, we're going to call that Y0. So we're going to come back out here. We're going to go down. And we're going to come back and make sure I get 0 here again. Double and triple check. Okay, that's within a tenth. And now my two holes are 6.745. I chose one end from the end. So 6.745. We're within 4/10, which on a mill is pretty darn good. We're going to go to the opposite extreme. Double check my 0 here to make sure that these ends are parallel. And again, within a couple of tenths. All right, in preparation to drill the first one, double check my 0 again. So I put a pointed bit in the drill chuck and made sure 0 ended up right on the edge, which it does. And I'm going to lock down my x-axis. And we're going to go in 2.641. That's within a tenth. Look right here, feel underneath, make sure I'm not going to run into any 1, 2, 3 blocks under there. And also, looking at this, it matches up pretty darn close with my dot, considering that was just a ruler very roughly going off that dot, which you can't see. So surprisingly, I double checked. There's the dot I wrote with a ruler based on this dot here. And it was pretty close. pretty close, considering this is a big dot to find an edge on, and you know what I mean. So that just gives me confidence that I'm in the right spot. So we're going to drill and ream. So the reamer I chose is a weird size I happen to have several of, 0.4373. And I want it to be slightly smaller diameter than the outer diameter that I've got to line up with, which is 0.454, so it'll have a little bit of an edge to prevent it from falling through. And I didn't want it to be too small. Originally I was going to go 3/8, like an even size, but I've got to grind down a 1/2 inch dowel to that size, so I'd rather not have to do the extra, what is this, from here. This would be like, that'd be like an extra 60 thousandths. So we're just going to save the extra grinding, because I don't think there's really any advantage to being dead on 3/8, for example. I mean, a size is a size, right? I've got to grind to it. So we use the micrometer to get there, and the surface grinder to get to that size. So that's what we're planning on doing. All right, getting ready to drill. We're going to start with a center drill. We're going to try and do everything I can to get this accurate. This isn't a jig borer, but we're just going to do our best to see how accurate we can make this. I'm going to start with a smaller drill bit before I go to the final size. This isn't a really deep hole. This material is only 5/16 thick, but it seems like it wouldn't be a bad idea. All right, so we're going to slow this next one down a little bit. It's amazing how close it got to that copper that I put here to protect the surface from the clamp. Not that I had to protect the surface from the clamp, I just wanted to. I have like 6 of these odd-sized reamers, so I cut this one shorter. Now, one thing that does is it holds it more rigid, so if there's some eccentricity in the chuck or something like that, it'll actually show up in the hole, which isn't ideal, but I didn't want to have to lower the table all the way to the bottom. And that's it. Now we'll go down and do the other side. You can't see it, but do the other side that's over here, and we'll be done with the fixture plate. Hopefully, we will double check that on the surface plate when we're done to make sure we're getting our 2.641 like we're expecting. Surface finish inside the hole looks pretty good. I don't know if you can see it. The reamer did a pretty decent job. So let's zip on down to the other extreme. All right, so I've got a gauge pin here, and these holes were supposed to be 0.4373. This pin is 0.437, but it's minus, which I think it makes it -2, which means there's a 1/2 thousandth under, and it is snug as a bug in a rug. There's no wiggle, and it rubs when it goes in. I checked both holes, and it's right on the monies. I wasn't going to show you the second plate setup, but I thought it was worthy of showing you just for the different setup, because that's interesting to me, so hopefully to you as well. So instead of coming from the sides, I came from the back so that I had clearance to get an end mill, like a 1/2 inch end mill down the front. And what that also meant was that I had to move the plate forward because these clamps were running into the edge of the plate. And when I tightened them, it would move the plate. So I stuck a 1-2-3 block on the outside. This, by the way, it's a good reason to have a bunch of 1-2-3 blocks. I bought some inexpensive ones from China, like 20 of them a while ago, or no, not 20, 10 of them. And I'm just about using all of them right here. And it actually works out really well because they're very close. They're not, if this was super precision, it'd be a whole nother world, but this is not. So anyways, the 1-2-3 block spaces them out from the adjustable parallels. Now this adjustable parallel is a little small for the task, so it's a little sloppy. There we go, I can tighten it up. But actually that wouldn't matter, because it wouldn't matter if this was canted at 45 degrees as long as I cut the whole front, because I'm creating a new datum to go off of. I just used the back because it was saw cut and very flat, or relatively flat. Alrighty, so we're over here at the surface grinder getting ready to grind these 1/2-inch pins. These are hardened steel dowel pins. And we're going to grind these down to fit in the jig to help align the parts that need to have the next operation done on them. My surface grinder came with a single point diamond, which works fine. Never had a problem with it. Get decent finishes out of it. But I recently ran across this Norton multi-point diamond, and I'm having better luck with that, getting better surface finishes, and I'm not quite sure why. If anyone has any input on that, I haven't read any documentation to say why it's one way is better than the other, but it seems to work better. I can't imagine that these points of these diamonds, since they're all random in this matrix that's fairly thick here, they're not going to all be at the exact same height, and I wouldn't think they'd wear very quickly, so they won't wear to match each other very quickly. But for whatever reason, I get a much better surface finish when I use this, so I've continued to do so. Love to hear your comments down below. Okay, so we've got my Spin-A-Ma-Jig on here in a 1/2-inch collet with the pin right down there. I know it's hard to see. And we're going to try and grind this pin down to 0.437. And its initial size should be 0.5 plus a couple tenths. I think this is a slightly larger than 0.5. 0.5003, 3/10 over half an inch. So I don't know if you're going to be able to see this. We're going to try and let you see it. Basically, I come down 63 thousandths. And on the last pass, I think I want to come from the outside in case there's uneven wear on the wheel. I don't want high spots and ridges, so I'm just going to take it down. We're down 10 thousandths here. So I'm down 34 thousandths so far in diameter. Okay, that's down 60 thousandths. So I'm going to call that 0, and I'm going to walk the y-axis out and take a measurement carefully. .381. I made that way too small because guess what? I fell for the oldest trick in the book. I took it down, but I was taking it down radially. And so when I went down a thousandths, I was taking 2 thousandths off the material, so I took twice as much as I needed. That was brilliant, right? Start over. Here we are in round 2. I'm going to walk this in to find my Y0. Okay, we're going to call that Y0. It's going to come back. We're going to go up a bunch. And I'm going to go in 320 thousandths, which I will call my new 0. That works. Now I'm going to slowly lower this guy until I just start to make contact. Now, there we go, right on cue. Very good. All right. So we're going to go in 29 thousandths this time, so as to not overdo it. Okay, that should be my new 0. And I'm going to come out so I can measure. Stop this guy from rotating. .4419. We need to go in another 2 thousandths total. Just going to let that go until it sparks out. and come back out. Then I am going to get a diamond hone, and I'm just going to put a slight bevel on the edge here so that I can test fit. Okay, I cleaned up the edge. Let's test the fit. Should have made a part that I reamed. There we go. Yeah, there you go. No wiggle. That'll Loctite in just fine. Okay, first part done. Now we need to take the outside of the next part to 0.454. Call that our new 0. And we need to bring this down until we just start to touch. There we go. Call that my Z0. So we need 26 thousandths, but we're going to stop well before then. That should be it. Looks like I went a couple tenths over, but that'll be within spec easily. I've got 5 thousandths. So let's do a test fit. So exactly what I want. No up-down motion, but side to side, because these are oval slots. That's absolutely perfect. Yeah, no up-down at all. Yeah, no up-down, side to side, which is absolutely perfect. All right, so we just need to make one more of these, and then I need to I need to cut off this piece and then grind the heights. Although the absolute height of the tall section is not important, it needs to be more than this, and that's it. Here is the first part with the 2 ends on it that'll be cut off. I'll part those off, and then we will grind the ends flat, and we should be good with those. I checked the measurements again now that the pin is out, and it's great fit. So should be perfect. And so we just got to make one more of these with different sizes. All right, so I only need 30 thousandths protruding, but I ended up making it closer to 100 thousandths. And I took a piece of scrap aluminum and drilled and reamed it with 4 holes to line up the buttons, and then I just ground them all to the same height. I got to deburr the edges a little bit, and then we should be ready to test it. All right, so I just pressed the pins in. These actually were slight interference fits, so I did not Loctite them in place. They can be Loctited later. And the vendor thought that these holes, when they gave me specifications, it was the center of the slot. It was not. You can see there's 0 side-to-side play. Thought I'd have a bunch. So this leaves a little bit of material sticking out here. And the point of that material, this one actually is ground, is to mount this guy along here vertically. So first they tack it, and then they finish weld it into place right along that slope. So that's the first one. And the second one is just simple alignment. And this one, if they fit a little bit snugly, because again, it's not the center of the slot. Their spacing was actually, oh, look at that. That one's going to have to, I am going to have to glue that one in. Yeah, because I made the very close to the exact size of the hole. So I'm going to have to glue this one into place. But you can see that these slots have 32 thousandths play, but when they gave me center locations, it was shifted to one side, and then they went out on both sides. So that kind of hosed me. It would have been nice to know that. But in any case, the part does fit. It's just a little bit snug. And all I can do is I can just take a little tiny, I can take to the Scotch-Brite wheel, just clean that up a little bit, and it'll probably make it smoother fit. Anyways, that's it. That was an incredibly interesting project. A whole bunch of new things I've never done before. This was to identify which one it goes with. Although there were other ways to tell, but that was just the easy way to do it. Anyways, thanks for watching. Hope you find it useful. Hope to see you next time.